we've looked at the sine and cosine functions, and the remaining trig functions, tangent, cotangent, secant, and cosecant, are defined in terms of sine and cosine. So that if I have a function f of x equals tangent x, that is defined to be sine x divided by cosine x. So every trig function can be written in terms of sine and cosine. My cotangent of x is the opposite, cosine x over sine x, which means it is 1 over tangent x. It's the reciprocal of tangent. So 1 over tangent is cotangent, 1 over cotangent is tangent. They are opposites, reciprocals. Secant of x. I don't know why I made that capital. Oof. Secant x. This is the one where the next two you have to really memorize. I mean, I know you have to memorize them all, but because secant is defined to be 1 over cosine x. And cosecant x is defined to be 1 over sine x. So the co-functions don't really go together. They go with the opposite ones. So these are just ones that you have to memorize in terms of sine and cosine. Let's see some examples on how you can find values of these. Suppose I am given that the sine of x is the square root of 3 over 2. And you will often see radicals here because they are exact values. Now what I want to do with this is to find every other function value. I want to find cosine, tangent, cotangent, secant, and cosecant values. Well, I know the sine, and remember that 1 over the sine is the cosecant. So my cosecant here, I can do immediately, is 1 over the square root of 3 over 2, which would just flip it, make it 2 over the square root of 3. I can do that one very quickly. And it's fine to leave a radical in the denominator. That's not an issue at the collegiate level. Let's see what else we can do. Well, everything else involves using a cosine, so I have to find the cosine. How do we find the cosine? Pythagorean identity. Remember that sine squared of x plus cosine squared of x is equal to 1. Or it's cosine squared of x plus sine squared of x equals 1. Either way. And I know the sine. So let's put the value in here. Square root of 3 over 2 squared. This is sine of x to be squared. Plus cosine of x to be squared is equal to 1. So I'm going to rewrite this. Maybe it'll help figure out my answer. Well, if I square the square root, I get 3. But you also have to square the denominator. So don't forget to square both parts of the fraction. Plus cosine of x squared equals 1. That means my cosine of x squared is 1 minus 3/4, which is a 1/4. So that my cosine of x is 1/2. You take the square root of both sides. And it could be plus or minus. Right now, I'm just going to look at the positive values. So I know my sine value. I know my cosecant. I now have found my cosine of x to be 1/2. And so I can now find other values because I now have both of the basic ones I need, sine and cosine. The cosine, if I take 1 over cosine, I get secant of x. That would be 2. And you don't think about it probably very often, but sine and cosine go between 1 and -1. Clearly, that's not the case with secant or cosecant. They both can be greater than 1. What do I have left? Tangent. Tangent of x is sine of x over cosine of x. The sine of x was a square root of 3 over 2. Cosine of x is 1/2. To think about the arithmetic, if you think back about those fractions you did, if I am dividing by 1/2, I multiply by 2/1. And when I multiply this, you can either think of, now I have 2 square root of 3 by multiplying numerators over 2, or just think about it as I could cancel the 2's and I get square root of 3. So my tangent here, being sine over cosine, ends up being equal to the square root of 3. What's next? Cotangent. Well, cotangent of x is cosine x over sine x. So in this case, I would put cosine is 1/2 over sine, which is root 3 over 2. And I would have 1/2 divided by that is multiplied by 2 over root 3, gives me 1 over the square root of 3. Well, yes, that's true, because cotangent is cosine over sine, but it is also 1 over tangent. So that's where my 1 over square root of 3 could come also. Either way you want to think about it. So I started off with just one value, and I ended up with a combination. Now, my assumption here was that sine and cosine were both positive, but I found the cosine by taking a square root, so it could have been negative 1/2. So that complicates matters. So let's do another example and see how we can complicate things. Let's let cosine of x equal negative 1 over the square root of 2. And this time, let's let the sine of x be positive. So in order to find my trig functions, I would have to use my cosine of x in the Pythagorean identity to find the sine. But first, let's think about, is the cosecant of x equal to negative square root of 2? Well, if the cosine of x is negative 1 over root 2, if I take the reciprocal of that, I get negative square root of 2. But is that cosecant? No. Cosine and cosecant don't go together. This is the value for the secant of x. So keep in mind that there are things you can test before you even continue just by remembering what's a reciprocal of what other function. Okay? So no, that's not the case. Let's see what else we can find. My sine is positive, so if I use the Pythagorean identity, I take my cosine of x, and please note that when you do that, the whole negative and everything goes inside a parenthesis to be squared. Plus sine x squared equals 1. So if I square my negative 1, I get 1. And if I square the radical square root 2, I get 2. 1/2 plus sine of x squared is 1. So my sine of x squared is 1 minus 1/2 is 1/2. And the sine of x then would be the square root of 1/2, either plus or minus, but I said it's going to be positive. So the square root of 1/2, I know you like decimals, but let's just think about this. Square root of 1 is 1, the square root of 2 is square root of 2. So we can write it this way. And there's no need to really simplify radical. This is a fine answer, and that would give us a value for sine. So I now know that the sine of x is equal to 1 over the square root of 2. So what is the cosecant of x that I was looking for before? And I decided it couldn't be this because that was secant. The cosecant of x is 1 over sine, and that would just be the positive square root of 2. So it does make a difference with signs in some of these problems, so be very careful with those. Given sine or cosine or both makes it a little bit simpler to do. Let's try one more complicated. Suppose that we're given that the tangent of x, the tangent, is negative 2 over 3 square root of 5. Ooh, hope I don't mess up the arithmetic here. Let's see how many of these we can figure out. Well, I know the tangent of x is sine x over cosine x. However, sine of x is not negative 2. Sine has to go between 1 and negative 1. And when we did these before, remember we had a fraction on top and a fraction on the bottom that ended up simplifying. So I don't really have sine or cosine. I know what the cotangent would be. It would just be the reciprocal of that, so I could get cotangent pretty quickly. But I'd really like to figure out what my sine and cosine are. So let's go to that Pythagorean identity. Let's go and do sine squared x plus cosine squared x equal to 1. Now, how is this going to help? Okay, well, it can make things a little confusing, but I would like sine over cosine. So how about if I divide everything by cosine squared? Divide the first term by cosine squared, divide the second term by cosine squared, and divide the other side by cosine squared. Okay. Ooh. Well, sine squared over cosine squared is the same as sine x over cosine x squared, which means what I actually have here is tangent squared. Tangent of x squared. Oh, good, I have tangent. So this is progress. Plus, oh, that's 1. Ha, yay! 1 over cosine squared. Do I want to keep it like that? Do I want to make it secant squared? Because 1 over cosine squared would be secant squared. Well, I'm kind of looking for sine and cosine, so I'm going to keep it as 1 over cosine squared of x for now. My tangent was negative 2 over 3 square root of 5, 2b squared, plus 1 equals this, 1 over cosine squared or secant squared. If I square this radical, it's so easy. Negative 2 squared is 4. I square the bottom. This is not as easy. 3 squared is 9, multiplied by the square root of 5 squared is 5. You just square each piece. Plus 1 equals 1 over cosine squared x. Okay. 4 over 45 plus 45 over 45 gives me 4 plus 45 is 49. Over 45 equals 1 over cosine squared x. Oh boy, this is so messy. 1 fraction equal to 1 fraction. What you can do with that is flip both sides. So this is 45 over 49 equals cosine squared x. Cosine x to be squared. As long as it's 1 fraction equal to 1 fraction. You could cross multiply and divide, but this is what you get if you have 1 fraction on each side. So my cosine of x, cosine x, is the square root here. If I take the square root of both sides, I'll have square root of 45 over 7. So, cosine of x would be square root of 45 over 7. Now, here again, plus and minus. What do we do about these plus and minuses? Okay, we'll have to make some kind of decision. So, when I wrote this, I wrote the negative on top here. I'm going to say the cosine is going to be the positive one. And the sine will be the negative one. So we have a couple of different ways to go after this. I know my tangent was sine over cosine. So I can go back to my tangent, this equation, and I have sine x over square root of 45 over 7 equal to negative 2 over 3 square root of 5, and I can solve. So sine x is equal to negative 2 over, and remember that 3 square root of 5 became 9 times 5. So this I multiply by root 45 over 7, and square root of 45 is 3 square root of 5. So they cancel. My sine function, sine of x, then is a negative 2 over 7. And if you think back up here now, see how this goes. If I take sine over cosine, sine divided by cosine, my 7s would cancel. I'd have negative 2 over the square root of 45, which is this, negative 2 over 3 root 5, square root of 5. So it's a complicated process if you don't have a sine or a cosine. I won't even give you one with the cosecant or a secant to work with, but you go through the same type of thing. Okay, so just watch out for these. Be sure and do the lesson examples and the lesson problem because they give you a lot more examples you can practice with. Now we want to look at the graphs of the remaining trig functions, tangent, cotangent, secant, and cosecant. About the best way that I know to do it is to think about the angles on the quadrant, on the axes. So let's put up a little table with the sines and cosines of the angles on a quadrant. So if I have my x as 0, pi over 2, pi, 3 pi over 2 and 2 pi. Then I want to look at the sine of x and the cosine of x as far as what the ones and negative ones are. So sine of 0 is 0, cosine is 1. You can think about that. Pi over 2, vertical y-axis. Y is 1. X is 0. Remember, on the quadrants, we think of sine as the y value and cosine as the x value of a point. At pi, sine is 0, cosine is negative 1. 3 pi over 2 is the negative y-axis. So we have a negative 1 for sine and a 0 for cosine. And 2 pi, we're back to 0. So sine is 0, y is 0, x is 1. Using these values, you can come up with a graph for tangent and the other functions. So for tangent, if I start at 0, tangent is sine x over cosine x. So sine over cosine, 0 over 1 is 0. Tangent goes through the origin. At pi over 2, I have 1 over 0. 1 over 0 is not defined. So at pi over 2, I have a vertical asymptote. The same thing would happen at negative pi over 2 because it goes down. It would be the same as positive 3 pi over 2. So over here at negative pi over 2, I would have a vertical tangent. At pi, I have 0 over negative 1 is 0. So my graph at pi would cross the x-axis. And at 3 pi over 2, I have negative 1 over 0, which is not defined. I have another vertical asymptote. Now you can check a couple of values, or you can just remember the basic shape of the tangent looks like this. We have it approaching the curve on the bottom, and on the upper right half, the way the curve increases always. So this is the basic shape of our tangent graph. For the cotangent graph, cotangent, remember, is cosine x over sine x. So it will cross at different places. So if I start at 0 and I have cosine over sine, it's 1 over 0, I have an asymptote when x is 0. When I get 2 pi over 2, the cosine is the cosine is 0 and the sine is 1. 0 over 1 is 0. It crosses here. So at pi, my cosine is on top, negative 1 over 0. I have nothing, so I have another vertical asymptote. Okay? Now with the cosine function, it's decreasing. So our curve goes a little bit backwards for cosine than it does, for cotangent than it does for tangent. And if I go over to 2 pi, I'll have another 1 over 0 with an asymptote, but it crosses at 3 pi over 2. So this is one of those cases where you basically memorize what the graphs kind of look like, but you can double check asymptotes and intercepts by knowing what happens with sine and cosine. Let's look at secant and cosecant and see what they look like on a graph. If I have y equal to secant x, remember that secant is 1 over cosine x. So wherever the cosine of x is equal to 0, the secant is now going to have a vertical asymptote. So the cosine is 0 at pi over 2. So at pi over 2, secant will have a vertical asymptote because I would have 1 over 0. At pi, well, let's go back to 0. At 0, 1 over 1 is 1. My secant is 1, just like the cosine is at 0. At pi, the cosine is negative 1. I'd have 1 over negative 1. It would be negative 1. At 3 pi over 2, my cosine is 0. I have another asymptote. Let's go in this direction at negative pi over 2. Negative pi over 2 would be the same as pi over 2. I'd have a 0, so I have another vertical asymptote. Now, the cosine curve, we know, starts at 1 and goes like this. The secant is the reciprocal. The secant curve goes down to 1. And here, if I extend this a little bit, it goes up to 1 and down. So my next piece of secant goes up like this. So if you know where the cosine curve is, you can go ahead and graph your secant curve. And you do something similar with sine and the cosecant curve. Now, I erased tangent, but remember how it just went in separate pieces? If you think about the period of a function, the period of tangent x was just pi, because it went between negative pi over 2 and pi over 2, pi over 2 to 3 pi over 2, just pieces. It repeats every pi units, each of those little swirls. This repeats. Negative pi over 2 to 3 pi over 2 is 1 pi, 2 pi. So my period for secant x is equal to 2 pi, just like sine and cosine. So the period of cotangent was similar in the graph to tangent, has a period of pi. The period of a cosecant, you can see that in the lesson, is similar to this, shifted, but the period is 2 pi. So we'll be able to look at some combinations of these and keep in mind what the graphs look like to help you figure out what the periods are. Let's look at two functions that this is a combination of two functions, and this is a function that's got a little complication inside here. So we want to find the period of this function, f of x equals cotangent x plus secant x. Now, cotangent is like tangent, so it has a period of pi. It repeats every pi units. The secant is like cosine, 1 over cosine, so it has a period of 2 pi. You do not add the periods. If you think about a secant graph having a, let me not put that there. A secant graph having a period of 2 pi, a cotangent graph having a period of pi means that to finish this, I'd have to have two cotangents in there. But that's okay. The period of the combination is the greatest. So the period of this function, the period of f of x, is 2 pi. Because it takes 2 pi to hit the biggest function, and so that's what you've got. Now for this function, this you have to go back and think about that equation we did. Cosecant is 1 over sine, so remember a sine b x minus h plus k. The b talked about how many cycles there were within 2 pi. To find the period, we can use the formula 2 pi divided by b. That would let us find the formula. This takes everything out. There's no a, there's no h or k. It's just sine of bx. This is cosecant of bx, so we use the same idea. So if I write y equal to cosecant, and I want to write b times x, this is 1/2 times x. So b is 1/2. It's not 2. So if I want to find the period, it would equal 2 pi divided by 1/2. If you divide by 1/2, that's the same as multiplying by 2 over 1. The period is actually 4 pi. So for my cosecant of x over 2, instead of having a period of 2 pi like sine does, because the x over 2, we have a period of 4 pi. So it is stretched out, and it takes a whole 4 pi for the cosecant to have one period.